Hi everyone. Hi Bailey, Valerie, Olive, Athena, Hendrix. A long time ago, Valerie asked me about static electricity, and I couldn't really show that to you because I didn't have the balloons. Now I've got them. Before I show you static electricity, I want you to remember something that I did with magnets. You might remember this, where I could get them to attract together, and I could get them to push each other apart, and I could use them to pick up metal objects like this. Okay. Now those are called permanent magnets. They stay magnetized all the time. There are also electromagnets, which only work when you have passed electricity through them. But then there's magnetism caused by something called static electricity. Now what happens with static electricity is that we rearrange the particles that matter is made up of. Now you may remember me mentioning that matter. Now matter, first of all, is anything that takes up space and anything that gravity can pull on is matter. So everything's made of matter. These solid objects are made of matter. There's liquids that I've been pouring, and so that's matter. And even gases like the air that I bubbled into a glass to force the water out, that's matter also. Now, matter is made up of really, really tiny, tiny particles called atoms, and different kinds of elements. We haven't explained what elements are yet, that'll come later, are made up of different kinds of atoms. But an atom, now remember, this is really, really tiny, is made up of the central portion here with positively charged particles in it. Now positive doesn't mean anything except that it's opposite of negative. This is like the sun in our solar system. And then surrounding the center of the atom are these little oppositely charged particles. Those are called electrons. And the electrons stay around this atom because they are attracted to the center of the atom because they're oppositely charged. Now you notice they stay at opposite sides of the center of the atom because they have the same charge and they repel each other, but they attract to the center of the atom. Now the one thing I cannot explain because nobody knows is why these positively charged items don't push each other out of the center of the atom. And we have a question from class. Granny?
What does repel mean?
Repel means pushes away. Okay, so I'll show it to you this way. Now don't worry, I'll put this back up again. Attract means they pull together. Repel means they push apart. Okay, so this electron and this electron are repelling each other, pushing each other apart, but they're staying with the atom because they are attracted or pulled towards the nucleus of the atom. Now, static electricity happens when something that normally isn't magnetic gets some characteristics that make it like a magnet. Balloons are a good example of that, because a balloon, because it's full of air, doesn't weigh very much, but it's pretty big because it's full of air. It takes up a lot of space. So what I'm going to do is see if I can put a static charge on the balloon. When you rub some objects against a fabric of some kind of cloth, you might be able to put some extra electrons on the balloon or take some of the electrons off. Either way, it becomes charged. Now, can we get that to attract two objects? Look at this. It's not attracting very hard, so let's rub it some more. Oh, there we go. Look at that. I can't quite pick it up, but I can pull it across the table because it attracts to my hand. Now, let me take another balloon. Do the same thing to it. And that attracts to my hand also. So, both balloons attract to my hand. Both balloons have a charge to them. Now, is it the same charge or is it the opposite charge? Well, did I do the same thing to the balloons or did I do the opposite things to the balloons? I did the same thing, so they both have the same charge. Now that means that they should repel, meaning push each other away. Let's see if that happens or not. It looks like it. Well, that's still attracting to my hand. Get my hand out of the way. But the other balloon is repelled, pushed away. Let me get a third balloon in here and see what happens then. Put a charge on this one. Get them all together and they fly apart because they repel. Why do they repel? They have the same charge. Why does it attract to my hand? Because, well, either my hand is oppositely charged or has no charge at all, and therefore can attract the neutral object like this magnet did with this piece of metal. Okay? Static electricity causes sparks sometimes. If it's a cold, dry day and you shuffle your feet across a rug and then touch a brass doorknob, bam! And you know what a great big static charge is? Lightning. Lightning is huge because in high winds, electrons are either scraped from the clouds into the ground or scraped from the ground into the clouds. Either way, whatever gets the electrons becomes negatively charged. Whatever doesn't get the electrons, loses them, becomes positively charged. And they attract each other with so much force that the electrons jump through the air, either from the ground to the clouds or from the clouds to the ground. And that jumping is lightning. It has so much energy in it that some of the electrical energy is turned into light, and then it's turned into sound. So you get the flash, and you get the boom. Oh, and by the way, have you ever noticed that the flash happens before the boom? That's because light travels about 1 million times as fast as sound. So when you see a lightning bolt, the light gets to you right away. It takes sound a little bit of time to get there. So now we know some other things about static electricity. Okay, well, thanks for watching, and goodbye.